Hope everybody is off to a great Friday, and let's see what's about to happen. As we take a look at our models and we go down through our questions, the first thing you were asked was to observe what was happening at that center slit. So folks, as we take a look right here down this slit, we should have seen the two colors coming up mirroring each other on both sides of the slit. So we have our colors mirroring each other on both sides. So what feature do we think that this represents here on Earth? Well, folks, when that material is coming up and we have these being pulled outward, let's talk about that. If those are being pulled outward, that's being caused due to tension, which causes that crust to become thinner. And folks, as we look at that model, that's representing the crust. So below that crust, which would be underneath the model, that would be your mantle. And we know inside that mantle are the convection currents that are causing the motion to move that crust. As our hot material rises and cools, it's pushing that material outward in both directions. Now, as it becomes thinner in the middle due to tension, up rises magma from the mantle to the crust, creating new rock. As it cools and hardens. Where that happens is known as a mid-ocean ridge. So what do these side slits represent? So as we take a look over on the right side and on the left side, what we notice here is not new rock coming up, but instead this rock is going back down underneath. Well, folks, we're working here with oceanic crust. And we know that oceanic crust is what density compared to continental crust? Hopefully you just said it's more dense. So folks, as it sees those side slits and it's matching up with either more oceanic crust or continental crust over along the sides, it's going to subduct back down in. So we get a subduction zone. As the crust gets recycled. And as that goes down in, remember, depending on what type of crust that it's meeting up with, we can either get trenches or it could also lead to some volcanoes. So now question 4, what does the space under the seafloor spreading model represent? Well, we just discussed that. That's the mantle, and that's where the magma is going to rise up from. So what might these different colors represent on the paper? So on mine, I have yellow and orange alternating. Folks, as that rock comes up and cools and hardens, it gets aligned to Earth's magnetic field. And just like a magnet, if we pulled a bunch of iron filings with a magnet underneath, we would see those filings kind of waving and moving back and forth. When that does that, it happens because it's becoming magnetized. So when we see these different coloring strips, these are representing different periods of time in the ionization of the minerals that are creating the rock. So these different colors of rock represent different ionizations and polarities of rock. So folks, currently, when we talk about a compass, and we're going to get much more in depth in this in the upcoming week, if we hold a compass up, it currently points to the north. But millions of years ago, where it's orange, it might have been south. Before that, it would be north, then it would have been south, and then it would have been north. So folks, as the convection currents are happening inside Earth's core, it changes our magnetic field, which ionizes those materials a little bit differently, which makes them appear as if they are almost different colored strands. So it's representing the polarities of those materials over millions and millions of years. And again, that's a topic that we're going to come back to early next week. Now, number 6, why is it important that the paper has identical patterns of colors on both sides of the slit? That's because the ocean floor is growing at the same rate both directions. Think of it as a conveyor belt like at a Giant Eagle or a Walmart or a Shop and Save. As it comes up, it's kind of going on forever in both directions. So as it comes up, it's splitting right down the middle as the materials are moving to the left and to the right. And we see that it gets pushed outward as new rock comes in. So how do the colors close to the center slit and near the side of the slits differ in age? Well, folks, as it comes up right in the middle, we've already said that's creating new rock. So as that new rock is coming up and it's pushing out the rock that was previously there, the further that it gets out to the edge, the older the rock gets. And we always find new rock closest to the ridge. So ladies and gentlemen, that's our process of seafloor spreading. Right? The fact that magma is coming up, creating new rock, and as it is spewing out from Earth's mantle, creating new oceanic crust and those underwater mountain chains known as a mid-ocean ridge, it's constantly pushing that new rock outward, and eventually it gets older and older and older till it hits that subduction zone and goes back down in. So folks, we have two things happening here. We have new rock getting created in the middle, and we have old rock getting subducted and recycled back at the end. Now, this is the theory of seafloor spreading, but just like any theory, there's got to be some concrete evidence to support it. So as we take a look at this, Harry Hess did a lot of work with our seafloor spreading, and he was able to identify a couple key pieces of information. One being the age of the rock. We know that we found the youngest of rock nearest to the ridge, and we found the oldest of rock furthest away from the ridge because it's getting pushed out as new rock is getting made. He also found these polarities in these ionized strips, and he saw that they were a reflection or a mirrored image on both sides. So we can see that it goes south and south on both sides, then north and north on both sides, south and south, north and north. And so one side is a complete reflection of the other. As they sampled the rock, not only did they find that in the middle was the youngest and outward is the oldest, they also found that the rock itself was pillow-shaped rock, which means that it's lava rock, and that lava rock can only be formed from cooling magma. So that also helps support the fact that there was magma coming up and cooling and hardening to create this new crust. All right, now that you've got this, let's make sure that we have all of this labeled on our seafloor model. We're going to insert a picture of this and then kick some butt on the next few questions. Have a great Friday, everybody.